In this problem, we are assuming that the amounts of weight that male college students gain during their freshman year are normally distributed. We have a mean of 1.2 kilograms and standard deviation of 5.1 kilograms. And so in part A, we want to determine if a male student is randomly selected, find the probability that he gains between 0 and 3 kilograms during their freshman year. So in order to do this, we look at the distribution and we see that the mean is 1.2 and the standard deviation is 5.1. So we can see from 1.2 to 6.3 we added 5.1. So we want the probability that the weight gain is between 0 and 3 kilograms. So to calculate this, I'm going to use normal CDF and the range is from 0 to 3, so that's our lower and upper. The mean is 1.2, and the standard deviation is 5.1. And that gives us a probability of 0.2309. And when we look at the distribution, we can see that this area here, does that reasonably look like about 23%? That seems right. And that is the answer to our problem. Now we get to part 2. This says if 25 male college students are randomly selected. So in part A, we were looking at the probability of one individual falling between 0 and 3 kilograms of weight gain. So we have one individual that's just X. But now we want to look at the probability that the weight gain, the average weight gain for a group of 25 is between 0 and 3 kilograms. So that's going to change our distribution. So now we're looking at a different distribution where the mean of the sample means is the same as the original mean, and that was 1.2, but the standard deviation of the sample means is the original standard deviation divided by the square root of the sample size. So this is going to be 5.1 divided by the square root of 25, and that gives us 1.02. So now we have the mean in the center here again at 1.2, but the spread is much smaller. So we have 1.02 for our standard deviation. So when we calculate this probability, now we're going to use normal CDF. Zero and 3 are still our limits. The mean is still 1.2, but now the standard deviation is 1.02. And when I put this in the calculator, I get 0.8415. So we can see that's a lot more area. It's a higher probability. And that looks about right. That looks about 84%. So that's how you do that problem.